Good day. My name is Dumisang Mutweni, and today I will be presenting part 2 of my PROC 6221 portfolio evidence, the Cybersecurity Awareness Chatbot 2. In part 1, I built a basic console-based chatbot that could greet the user, play a voice greeting, display ARCI art, and respond to a small set of cybersecurity keywords. In part 2, I significantly expanded the application by adding a full graphical user interface using WPF, Windows Presentation Foundation, as well as several advanced features including keyword recognition, random response, memory and recall, sentimental detection, conversation flow, and error handling. Let me walk you through the application and explain how each of the feature was implemented. Project structure. The application is structured across 5 C# classes files, each with a single responsibility. The 5 files are app.xml and app.xml.cs, the WPF application entry point that launches main window. Main window.xml, the XML layout file that defines the entry user interface. The main window xml.cs, the code behind that handles all user interaction and events. Chat.cs, the core logic class that processes inputs and return responses. Greetings.cs handles the voice greeting and uses system.speech.synthesis. IKEY Art Helper.cs, retained from part 1, provides the IKEY art and wink animation. Separating logic from the UI means the chatbot class has no knowledge of the WPF. It simply receives a streak and receives a streak. This makes the code clean, testable, and maintainable. The graphical user interface. The GUI was built using WFP, Window Presentation Foundation, which is one of the 2 GUI frameworks specified in the project's brief. I chose WPF because it supports XML based layout, which gives great control over design and styling comparing to WinForm. The interface uses a dark pink and purple color scheme, which gives the application distinctive and professional look. The layout is built using a deck panel which stacks for 4 sections vertically. The title bar at the top displays the application name in a pink to purple gradient. The memory bar shows the user's stored name, favorite topic, and the last topic in real time. The chat display area, a rich text box that shows the conversation with color-coded messages. The input bar at the top bottom contains a text box for typing, a send button, a clear button. User message appears with a dark pink label that says you, while bot's message appears with a purple label that says bot. This makes the conversation easy to follow at a glance. The send button submits the message and press enter or the key does the same. The clear button resets the chat and shows the welcome message again. Keyword recognition. The second major feature is keyword recognition. The chatbot can identify specific cybersecurity topic in the user's input and respond with relevant information. This is implemented using a dictionary that maps each keyword to a list of response. The keywords currently supported are phishing, password, malware, scam, privacy, firewall, ransom, VPN, and two-factor authentication. I chose a dictionary over a long chain of if-else statement because dictionaries provide fast lookup and make the code more easy to extend. Adding a new topic simply means adding a new entry to the dictionary. No restructuring of the logic is needed. To prevent the chatbot from feeling repetitive, each key maps to a list contains 3 different responses. When a key is matched, the chatbot uses the ransom clause to select one of the responses at random. This is handled by the pick random help method, which takes a list of string and returns a randomly selected item using random.next. The benefit of this approach is that users get a variety experience every time they ask about the same topic. It makes the chatbot feel more dynamic and less like a lookup table. Using a list of random selection and encapsulating the logic is a private helper method. Memory and recall. The memory feature allows the chatbot to store information about the user and reference it in later response. 3 private string fields store this information. Firstly, username. It stores the user's name when they introduce themselves. Favorite topic stores the topic the user expresses interest in. Last topic stores the most recent discussed cybersecurity topic. When the user says something like, "My name is Dumi," the chatbot extracts the name, capitalizes the first letter, stores it, and responds with a personalized greeting. In subsequent response, the chatbot prepares good question. Dumi is to reply, making the conversation feel personal and engaging. If user mention they are interested in a topic, for example, I am interested in privacy, that topic is stored as their favorite. Later, if they ask about it again, the chatbot adds a memory note reminding them that it is a recent and favorite interest that they uploaded. The memory bar at the top of the GUI updates in real time after every message, showing the current stored value. This was implemented as a label bound to the get memory summary method on the chat class. Coding, quality, and OOP. Throughout the application, I applied object-oriented programming principles and a good coding practice. Encapsulation. Private fields store states. Public methods expose only what is needed. Single responsibility. Each class has one job. Chat handles logic. Main window handles UI. Greeting handles audio. Arc help handles visual. Dry principles. The pick random helps method. Dry principle. The pick random help method is called whenever random selection is needed, avoiding repetitive coding, meaningful naming. All variable, method, and field have descriptive names that clearly communicate their purpose. In text citation, every section of the code is cited to knowledge the source that informed it. The user of dictionary, list, and array data structure throughout the project demonstrate knowledge of different collection types and when the applied each one appropriates. In conclusion, the Cyber Security Awareness Chatbot 2 successfully filled all the requirements of Part 2 of the POE, a functional WPF GUI with a consistent deep pink and purple theme, keyword recognition using a dictionary data structure, random response using list and the random class, memory and recall using private string field, sentimental detection using 3 list collection and LINQ, conversation flow using the following follow-up list and topic tracking, error handling with guard clauses and default response array, code optimization using OOP, help methods, and appropriate data structure. The application is ready for further expanding in Part 3, where the GUI and the logic can be expanded with additional features. Thank you for your time.